Hello, Cardinals. We are at the end of our energy, force, and motion unit, and we will be beginning our performance assessment today. Our focus question is, how do people use an understanding of energy, forces, and motion to make predictions and design tools that make our world safe, enjoyable, and accessible? And we'll be creating a fruit cart and testing that over the next couple of days. Little review from yesterday. Number 5, just a chance for you to talk with your group and discuss which of the following was criteria and which were constraints, and then understanding that there are a few restrictions. For example, you cannot tape or glue to the product, the fruit. Your vehicle must transport a large quantity of produce, and it must be able to support the produce while going up and down a hill, a sudden change in velocity, and a collision with another vehicle. So our objectives for this lesson is to complete a performance assessment by constructing explanations and designing a solution, and making predictions about energy and motion, and use evidence to support your predictions. Remember, the key word there is evidence. So your supplies available, this is per group, is 2 craft sticks, 2 straws, 2 pipe cleaners, 2 note cards, a half meter of tape, 1 brown paper bag for just holding stuff. You cannot use the paper bag in your design, but that's just for holding things. And of course, scissors for cutting. The requirements for the fruit cart modifications are, it must be removable and cannot be attached to the car. So you're not allowed to tape to the blue cars. It must be removable. You can only use the supplies available. It must be freestanding, which means you do not need someone to hold on to it. When you create this, it needs to stand up by itself. The fruit may not be taped or glued. There's no replacements, no replacement materials for bad cutting or breaking the supplies. So before you cut a pipe cleaner or cut a toothpick or a popsicle stick, make sure you want to. You're not getting a new one if you mess up. And items can be traded 1 for 1 with another group. So let's say you're in need of a 3rd postcard and another group is in need of a pipe cleaner. You could swap those items 1 for 1. We're going to go over the setups now. The first one is the setup for going up a hill. There's a board with a pulley attached to the end of it. And on the bottom of that pulley is a rubber stopper just for stability and grip reasons. And then you'll have 3 books there. And you'll be using 2 washers to test the car going up the hill. The next setup is setting up for going down a hill and a crash. This is kind of 2 for 1. You're going to use that same setup with the pulley at the end and that rubber washer on top of 3 books. Only this time you're going to move it to the floor. And your car will go down the hill and crash into another car that is a half of meter away, so 50 centimeters away. And in that car, there should be 4 washers, so it has some weight to it. The last one is the setup for a sudden change in velocity. You're going to be using the same board and pulley system. This time you're going to have it flat, so the pulley will be sticking over the edge of the lab station. You will hang 2 washers from the paper clip, and when you let go of the car, that will be the sudden change in velocity. So your to-do list for this assessment, remember this is on 11 by 17 paper, and there is a rubric to go along with this, is to go through all 14 steps. And you will have 2 days in class to get this done. If you have any questions, please let your teacher know.